So, hello. So I would like to welcome you on our presentation, which will be about post-quantum cryptography in OpenSSL library. It will be by me and by my colleague. So you will get knowledge about us, something, what is new in OpenSSL, what we did and what we released. And we will talk about post-quantum cryptography, what we have in OpenSSL. So, something about me. Some of you know me, some of you doesn't know me. So, I am engineering manager, so I'm responsible for development and all engineers in OpenSSL. I'm more than 2 years now in OpenSSL. Before I was working around 16 years in telecommunications. As we do tick profiles, so I'm Eagle Peacock. If you want to know more, go to tick.com.au and you will find out more things. And from my profile means that I like nice things and tasks done, which is bad for my employees. So what I'm trying to do is I'm trying to do agile development or introduce agile development in open source, which is not so easy because simply I don't own resources, which is a problem. Yeah, because I can't say you will be working on this because they simply will work on what they want to work on. So that is kind of challenging, but that is open source.
So my name is Norbert, Pócs, and I started at OpenSSL like half a year ago. Before also like ex-Red Hatter. Just to mention the tick profile, so my birds are double, which means I like precise stuff. And also I like to help people, which comes very handy for Tomáš because I do whatever he asks me to do. He's my manager, he gives me a job, I do it. It's challenging, but it's also always something new, so it's interesting.
Okay, so some past in this year, in April, we released 3.5, which is really important for us and for the rest of the world because we added post-quantum cryptography. And not only that, and we added also server-side QUIC. I don't know if you know the QUIC, most probably yes. And important thing which maybe some of you are not aware, that is support for third-party QUIC stacks. That is interesting thing because that is like TLS layer on QUIC stack. Currently is implemented in Microsoft QUIC, in Quiche and NGTCP2 stacks. So you can find OpenSSL almost everywhere as usual. So next thing which is really important for us, 3 weeks ago, we got submitted into FIPS validation. So our 3.5.4 release is submitted finally, which is good. And we are getting validated for 140-3 certificate, which unfortunately takes something between 13 and 16 months. So next year, this time, most probably we will have a certification, we hope. So next thing which happened 1st of October is that we released 3.6. I think important things, because I see Dimitri, that is EVP ASCII thing, which was developed by him, so I have to mention it. Another thing which is important for companies is LMS, which is another important protocol which is used by Cisco and others, especially in their VPNs. So it's important, and we deprecated another method for ASN1 because we are finally close to start removing things from OpenSSL after many years, because we didn't remove anything yet. So more fun will start. So I will talk about why we did it. So important thing is first thing I will start with quick, because that is important and is kind of related. And you can see on this chart that in blue is TLS 1.3, which is well known, and it's new TLS. And there is also TLS Quick, which is still consuming significant part of the traffic. We are getting that from Cloudflare. I need to mention that because it is only open data which we can get. No one else is providing this data for free, and they are usually really well hiding that. So you will not be able to get that. So an interesting thing on this is that it's visible that TLS 1.2, and which is visible as a green, and 1.1 and 1.0 is slowly dying, which is good, but it's still not dead. Yeah. And important is, I think, the HTTP3 Quick, which you see here as a significant portion, because that is getting used more and more, but unfortunately, I think it was planned that will be used much more heavier than is now, because finally they find out that it's not that quick as name is say. Yeah, it's slightly slower than HTTP2, so that is slowing down implementation, but most of the traffic is on YouTube, which is using heavily quick. Next thing is post-quantum, when you can see that in 2023 there was no post-quantum used in the traffic. Then in beginning of 2024, first few algorithms appeared, that ML-KEM thingy for key exchange. Then it was big jump that it started to do standardization in May, and then finally standardized around October 2024, and that was also reason why we started implementing it. And from 2024 it jumped, and it's still jumping. So you can see that almost half of the traffic now is using post-quantum. So if you are waiting with implementation of post-quantum, yeah, most probably it's the right time to start. So what algorithms we added? We started, as some of you are familiar with FIPS, so NIST as a standardization platform for US government and Canada finalized standardization for FIPS 203, 204, and 205, and they did it finally quite quickly, because before that standardization takes several years usually, and they did it like in 2 years and was quite quick. So there is quite big demand, and they are looking to have something really important to have it as soon as possible. And as we changed OpenSSL and we have more developers, we said that it will be fine to not leave our users behind, so we added. And it was finally, I think, first time when OpenSSL was one of the first who developed something new, because before it was always few years after everyone else have it, then OpenSSL added that when it was already too late almost. So that is good thing. And as you saw on the previous chart, that browsers implemented PQC really quickly. So there is no reason to wait. And we are trying to solve that I always saying buzzword is record now, decrypt later, what everyone is saying, because that is what is happening now. That everyone is trying to record all the traffic with idea in mind that once we will have quantum computer fast enough, they will be able to decrypt it. If it will happen or not, hard to say. We don't know. They are saying 2030, maybe we will have something, but we can have something in 2 years, and we can have something in 100 years. We don't know. So I will talk slightly about post-quantum approaches, which are taken for, which should be implemented, and mathematical guys, which are cryptographers, are dealing with this. Right now we have only 2 algorithms as a lattice-based and 1 hash-based. New one which is coming, it's called HQC, and Norbert will mention it, is code-based. And there is another one which is getting standardized, which is lattice-based and is called Falcon. It's not yet standardized, that's why we don't have it. Because there is a problem with that until they are standardized, we don't know how key will look like. And simply, we can't, or let's say, we can, but no one else will be able to read it. So we need to wait for someone who will standardize the output and say how key should look like to be able to say, yes, we will use it, and someone else will be able to read it. Otherwise, that cryptography doesn't make sense much if you can create a key which no one can read. It's super secure, but it will not help. So ML-KEM is the first one, is called FIPS 203 on the NIST side, and is used mainly for, as is in the name has, is key encapsulation mechanism. So you will find it as a part of hybrid algorithms in TLS right now. So ML-KEM is used for that key exchange. And is lattice-based, as it says, ML module lattice. Yeah. Next one, I don't know if you know, but in OpenSSL we have one specific feature which is called speed. And with -KEM algorithms, you can get comparison, not in this nice table. It will be horrible text and you have to dig it. But finally, you can get this nice table. It will take a while, but you will get it. And important thing on this table is that if you will compare RSA and other algorithms, you will find out that new post-quantum algorithms are not that slow, which is good. So you don't need to be worried that post-quantum, a new algorithm is slow, which is perfect. So next one, which was introduced, FIPS 204, which is ML-DSA, so module lattice-based digital signature algorithms. And according to name, you can really know or already know that it's used for digital signatures. I want to mention one thing because OpenSSL has one small thing that when you do the digital signature, you have to load everything into memory. And you can't use OpenSSL directly as a command line for signing huge files. And for that, you need to do calculation of external mu, which is described on its side, how to do that, and then do signature on OpenSSL. So we support that, but you have to develop some code. It's not from command line. So be careful if you want to sign 2 terabytes and you don't have 2 terabytes of memory, most probably will fail. So next one, which was standardized, is SLH-DSA, which is hash-based. That is only one which is hash-based right now. Is standardized, is FIPS 205, and has exactly same purpose as ML-DSA, and is considered as a backup. It's considered as a slower algorithm and safer algorithm. And because it's slower, significantly slower, most probably will not be used heavily until someone will hack ML-DSA. So how it happened? 3.5 last year, this time, we replanned that because we find out that post-quantum is here, so we need to do something with that. And we start looking what to do with it, because implementing it from scratch, yeah, we will not be able to do it quickly. So we have good relationship with Boring SSL, so we had a look, and they had it. So we agreed with them that we will take it. The one fallback for us, or bad thing for us, was that was written in C++. But OpenSSL is C-based, so we had to rewrite everything. During the rewriting, we found some issues, so we reported to Boring. So we improved Boring finally. Yay, open source works. And we added more features than boring SSL. So finally, OpenSSL implementation of post-quantum is slightly better than boring SSL because it's boring, yeah, SSL, so no one cares. We are active in IETF, so we are trying to fight with people like Microsoft, Google, and other big companies that their format is not right, and we are trying to get it right that will be usable for everyone. And it's sometimes really hard. It's not funny. And if you are interested, IETF is starting, I think, next week in Montreal. It's quite far, but you can do it online. We have it implemented in command line, so you can use it. You will see how to use it. Norbert will present it. And as we have quite good relationship with OQS provider, because Michael Bench worked for us also and for IBM as an OQS provider developer, so we have really good relationship, and he was helping us to develop. So we tested that with OQS, and we are sure that that it works with OQS. And as we have also good relationship with Bouncy Castle, I don't know if you are familiar with Bouncy Castle, it's a similar thing for Java. So we are testing that also with Bouncy Castle. So just summary, I will just quickly go through that. So we have ML-KEM, ML-DSA, and SLH-DSA. We have added hybrid key agreement in TLS, which is this horrible name, X25519 ML-KEM 768, which is that post-quantum, what you see on the charts on what browsers are using, which is combination of Diffie-Hellman and ML-KEM together. Yeah, that's why it's called hybrid. I think that there is not yet any browser which is doing pure ML-KEM key exchange for now. Maybe some testing, but it's not used in production heavily. We try to address record now decrypt later, what I mentioned. It's a buzzword. Everyone is using it, and it's marketing, huge marketing around that, and everyone is trying to do that. We have CLI and API, and other things like use cases and hands-on examples will be on Norbert, so you will see it soon. So before we will continue, I would like to ask, who knows OpenSSL? Yeah, that's perfect. Who knows, or who use it as a CLI? And who use it as a developer? Okay, so you have some audience who will understand. Thank you. I'm giving it.
Thank you. Thank you, Tomáš. So let's continue with some practical examples. I would say if you have a free weekend and you want to do something unusual, interesting, something you want to try out, then I will give you some examples or something you can dive into maybe. First, I would like to start with the CLI tool. We would like to create a signature of a file here. We will walk through that. And also at the end, I would like to introduce some C code, but later that. So let's start. Let's do some signatures. What do we need for that? We would like to do it with certificates. So first, we need to create certificates, of course. Let's start with the C, the root certificate. For that, we need to generate a key which we can tie the identity to. Here, we're going to use a post-quantum algorithm called ML-DSA. So we generate a key. Then we're going to create a root certificate. Here, I just would like to mention that you can see that there is like a CA true extension, and it gives permission to sign certificates, which is like crucial because that's what is it for. Here we show how basically it's done with post-quantum cryptography, but afterwards creating the keys is basically the same method as you usually do. So now we have a root certificate. We would like to create an entity, which is basically the same. We need first a key, and then we would like to extract the public key from it. And then we use a certificate sign request. It's useful when you are not the certificate authority and you want to ask for a certificate. So you create this request, you send it over to the CA, which will send you back a certificate. They might use this command, they might not, I don't know. The crucial part here is that you can see that the CA is set to false now, which means that this is an end entity and cannot sign any more certificates. All right, so let's create one more end certificate, but using ML-KEM. As I said, it's the algorithm for the key. All the different, like all the other part is the same. So we're gonna extract the public key from it and create a certificate. What's different here is that we don't use a CSR, and this can be done when you usually do it locally. So you are basically the CA, so you can skip that part and just create a certificate right away. Now we have certificates. How do we know that they work? We can try. So let's start the server. We load the key and the certificate we just generated. It's running. Then we try to connect it with the client. We use the CA certificate and verification of the host. We see that the connection is established, so it's fine, it works. Also, in the output, we can see that the negotiation was done using a hybrid algorithm using X25519 and ML-KEM 768. And the signature is ML-DSA 65, which we just generated. So everything is fine. Now we can move on and try to sign a file. Here we're going to use a kernel file, but it can be anything, basically. So we use this command and create a signature, and then we try to verify it. Verification is successful. Then we also would like to know, like, who actually signed this file. So we can output the signer here, and we can verify it, that who did the signature and what is the validity of it. All right. So the seed. Who knows what the seed is in cryptography? OK, OK. It is actually what you would like to have here, but we have a problem. In the post-quantum, the keys are generally big, a lot bigger than the classical algorithms. So we would like to keep it smaller, right? Small, fast. That's what we need. There is an option when we generate key pairs and generate a private key to only save the seed. Because the key generation uses a deterministic function, we can just give it the seed itself, and it will generate the same private key. And that will save us space. But also, you have to pay for it with the computational power, because every time you just have to recalculate the same key. Well, it probably depends on the environment and what you need. OpenSSL defaults to save the private key and the seed itself. And it looks like this. This is a private key. There is some bytes in the beginning, which is the seed. You probably can't see because of the private key. And if you don't want that, you can just do this. This is the seed. It's quite like a difference. So let's see. We have the seed, but want to private key. What to do? We can just extract the value here. We can use this command to get the hexadecimal number of the representation of the seed. And we can use this command with the option pkopt and giving it the hex seed option, and it will generate us the same private key. All right, so a little bit about the future of the post-quantum cryptography. There are two algorithms waiting for standardization by NIST. There is no draft for both algorithms currently. One is the FNDSA, which is based on Falcon. It's also lattice-based and waiting for digital signature, to be used for digital signatures. And HQC, which Tomáš already mentioned, is a first code-based algorithm. What is code-based? It basically uses error correction codes. And yeah. So this is selected for the fourth round in the NIST, and probably going to be the first one by the code base, which is going to be standardized if it's going to be. I would like to mention here the OQS provider. If you want to try out these algorithms maybe on that free weekend, you can try it out with OpenSSL, but with an external third-party provider called OQS provider. It is only meant for testing, shouldn't be used in production, but you can try it out and play with it. I would just like to mention that HQC is currently turned off because there are some security issues related with the algorithm, but it's still there to try. And now let's go back to code. Let's show some C code. I would like to go through key encapsulation mechanism and some signature also. So about the key encapsulation, I would just like to say in very short what it is. So imagine how cool it would be if you would have the public key of someone else, and you could just encrypt the symmetric key and send them over through a non-encrypted channel. And that's actually what the key encapsulation does. Yeah, some C code, let's go. At Alice, we would like to generate a key pair again. We need the public key and send it over so our friend Bob can encrypt his key with it. So we extracted it here, and then at Bob we would like to also use the key. So we use a VPP key generate here. But if you say it's something wrong, then yes, it is, because we are not generating keys here, but because OpenSSL is a little bit weird, we use generate here. But first, we call a param_gen init, which means that we are not going to generate keys, only the parameters for it. So we can later just import the public key of Alice. Then we initialize the encapsulation. We query for the sizes of the shared secret and the ciphertext, which is basically encrypted shared secret. Then we allocate the memory and do the encapsulation, so we get the ciphertext and the shared secret. So the ciphertext is safe to send over the network. We send it to Alice, and she can start the decapsulation, also needs to query for the size, allocate the memory for it, and then get the shared secret. At this point, both Alice and Bob has the same shared secret data, which they can use for deriving a symmetric key, usually like HKDF or similar. All right, that's for it. Let's look for the signatures and verification. Previously, we already generated some ML-DSA keys. We can use it here. So we would like to import and then do a little sanity check if the algorithm matches. If not, that's very weird, but might happen. Then we explicitly fetch the signature and also start the signing process. We need to query for the sizes as always, and then just get the signature of it. at the other party, we also load the public key, do the sanity check, fetch the algorithm, and then we're going to verify that the message that we just signed earlier actually matches. And that's it for me. Thank you. Tomáš, please continue.
So, and maybe you wonder why we are asking for help. We are open source. We have community, and we are looking for people who can help us. So, if you are working in a, as is mentioned here, company, institution, or organization, Red Hat and other universities, other small companies, then we'll be happy if you will join our communities. We have website, OpenSSL communities. Soon you will see a QR code which will help you to go to the website. And some of you know, like Dimitri knows, that I know. And you can be part of it. So you can do discussion with us, what next should be developed, what's burning for you, what you want to have it there, and also be part of our communities and advisories, because we have back and tech, which is back is business advisory committee and tech is technical advisory committee, and people are elected every, I think now 2 years or 1 year or 2 years, something like that. And they are working with their responsible community, and they are giving us advices what to do next. And it's really important for us, because before there was significant disconnect. On GitHub we had discussions, but that is usually only developers. That is not interesting for business people or people who are not writing the code but still using OpenSSL, because they simply don't understand most of the things which happened there. So that's why we started doing that, and we have people from Cisco, Microsoft, and other big and Red Hat, of course, and other big companies, and also small companies which are trying to help us to find the way what we should develop and what is our next journey, let's say. And it's fun right now, because it's quite undiscovered thing, and we are really looking for input. So if you want to join, and I will be more than happy if you will join, that will be perfect, because you can get some input and you can get some influence, which is interesting, at least for people that you don't have to be developer and still you can affect open source, which is different. I think that no other open source is doing that this way. So now we have time for questions, if there are any.
How hard is it to get developers to actually understand the implementation and do it? How hard is it to get developers who actually understand the implementation and verify it is correct from both enterprise and community?
Good question for the
Are you asking for the person who uses the library or develops the library?
Both. Mostly developers of the library itself.
Of the library itself. I would say the code base is quite large and a lot of small pieces, right, Dima? So I think it's pretty hard and takes a lot of time to understand the whole code. So yeah, it takes time.
A quick reply to you. Normally, you don't have to check the implementation of algorithms. Well, if you try, you will feel huge pain. But significant part of the surrounding code, TLS stack, some other areas, SMIME, CMS, are suitable for understanding from the external side, with a little help of GDB, of course, and now probably with a little help of ChatGPT. So it's doable.
So for OpenSSL, you said that for I forget which algorithm, but it saves both the seed and the private key. Do other implementations choose to save seed or private key or both as well? And why did they choose to do that?
I think they do it mostly for compatibility reasons. So everyone usually saves key and seed. Yeah, that was agreed on IETF, and this is the format what is used.
Do you have any candidate? Do you know? Can you tell me why Falcon is not yet standardized, and if there are any other algorithms which have small signatures? Because for DNS protocol, the huge signatures of post-quantum cryptography is a big problem, and we don't care about private key size, but we care very much about public key size and signatures, and it is kind of hard to use it in current algorithms. Is there work going on that? And
there is always in NIST, they do like exhibition or something that they select something, and that is selected for standardization. So for KEM, next one will be Falcon, which is smaller sizes, and HQC, which will be for digital signatures. And I don't know about any other which was selected yet. Most probably more will come. And I learned 2 weeks ago in chess event on BUT University that HQC should be the standard algorithm for German government. So they want to use it. And as you are mentioning DNS, I think not only DNS has a problem. Also, Quick has a problem with key sizes, because when you start using post-quantum, the problem is that key doesn't fit one packet, and usually fits 3 packets. Yeah, because it's UDP based, and then most of the implementation will have a problem, because at least we had a problem in our own implementations, and we find out, oops, it's coming in 3 packets, and we have to fix it. So, and other implementation has exactly the same problem. So. Falcon, yeah, we are looking forward. I heard something that somewhere in spring maybe will be something standardized, and I heard about HQC. If it will be or not, we'll see, because there is a pressure from government and from European Union. But if it will be or not, hard to say. Originally, normally it takes several years to get standardization, and they were selected like this year. So for standardization in NIST, I mean. Yeah, Falcon was, I think, 1 or 2 years back, something like that. Yeah, there is for a while. But it's unpredictable, and NIST is understaffed. And with all the things which is happening in US government, everything is slowed down. Yeah, there is even not happening rebranding. It's simply, they are shut down, because government is shut down for several weeks already. So you can see on their website, which is written, we are not updating website because we are shut down. Yeah, so now is everything stopped in NIST, and we can't do anything with that. So it's fun.
Nothing going to change soon.
Yeah, most probably not.
One more question, if you don't mind. Do you have any plans to support, for example, for the KEM, which is also mentioned by, I think, German government as a standard?
Usually, OpenSSL should implement only things which are standardized.
Yes.
Once it will be standardized, we will implement it. Yeah. Until it will be standardized, we will not implement it. We are now talking about doing some experimental version, how we can do that. We already started with HQC. We have it mostly done. So mostly we have it implemented. It's not publicly available yet because it's work ongoing. If it will be publicly available, we will see. We need to find a way how to do that, that we will have huge disclaimer for users. Don't use it in production. It can change. Because there is a problem with key format, yeah, which is not standardized. So we can do whatever we want, but if seed will change, it will be not readable in future. So it's just for testing purposes. So. Any other question? Okay.
I have yet another one. Is there a possibility, do you know, you showed some numbers how post-quantum is already used. Do you know how often it is used by serving dual algorithm on the same server socket, and how often already it is used by serving only post-quantum certificate and nothing else? Do you have different numbers for those?
No. Because we have only what Cloudflare reports, and right now in post-quantum it is used only the hybrid version, nothing else, and the pure is simply not used. And if it's used, we don't have the data. And really, the problem is that no provider reports this data, these statistics. They are completely hidden, and they don't do it for purpose. So they don't want to show it because it can destroy their business. Yeah, like they can say, yeah, everyone is using Quick, but in statistics will look, oh, only 20%, sorry. So they will lose funding. So it's tricky. So if there are no questions, thank you.